Hello guys, this is Navin Reddy. In this series of tutorial, we'll talk about Java 8 features. So the latest version of Java, which is Java 8, has introduced lots of features. And one of the most important features of Java 8 is Stream API. Now when we talk about Stream API, it helps you to calculate data or it helps to process your data. So in the world of big data and Hadoop, we have something called as functional programming. So till 1.7, we used to work with object-oriented programming, so everything was object. But in case of Java 8, we got a new concept called as functional programming. Now, what is functional programming? Functional programming simply says you don't have to focus on how to do things, you just focus on what to do. The remaining part will be handled by your Stream API. When you talk about object-oriented programming, you have to focus on both the things. First, what to do, and second, how to do. So we'll try to use a Stream API in this series of tutorials. But before understanding the importance of Stream API, let me go with the example. So let's say I have a main function here. In this main function, I have an array list. So to create array list, we have to say array list integer. We need all integer values, and we'll say L. And to create an array list, we can do one thing. We can create a list instead of array list. Okay, and then one of the way to create the object of array list is using this arrays class. So you can simply say arrays.asList. And in bracket, you can pass the values. So let's say values are 1, 2, 3, 5, 6. So you have 6 values here. Let's import the package which is arrays. So we'll say Ctrl-Shift-I to import the package. Now in this scenario, what we need to do is let's print all these values. So in order to print these values, what we need a for loop, right? So basically, you can go with the normal for loop, you can go with enhanced for loop, or you can go with iterator. So initially, let me go with the normal for loop. So I have to say for, I have to say int I, the value of I will be 0, and then I less than, let's say 6, and I plus plus. Since we have 6 elements, we have to reach till 5. Now let's print this value. So we'll say s out, and we'll say L dot. So in this L, you have a method called as get, in which you have to pass the index, which is I. Instead of L, let me give a proper name, which is values, and somewhere here in this L will say values. And if I run this code now, you can see the answer is 1, 2, 3, 4, 5, 6. Right? So this is how we can print values. So instead of using this logic, what we can do is we can use a second way. So we can just comment this part. Now the next way of printing this value is by using an enhanced for loop. Or we can use iterator first. So we can define an iterator. So iterator, it's an interface in Java which belongs to our package java.util. We have to specify which type of elements we have, integer, and we'll say this is I. And then since you want to create the object of interface, you can use a list which is values, because in this values object you have a method called as iterator. So using this iterator method, it will return you the object of iterator. Okay. Now once you got the object of iterator, we'll navigate in that iterator. So all the values from this values object will go to this iterator object now. So let's navigate. How to navigate? We have to run a while loop, and we have to check if there's any element next. So when you are at the first position, you will say, okay, check the element, okay, you have 1. Then check 2, you have 2. When you reach 6, it will say, what next? It says, there's no value after 6. So it will say, okay, let's break the loop. So it will run this loop from one value, the first value to the fifth value or the sixth value. So in order to print this, we'll say system.out.println and we'll say I.next. So has next will return your Boolean value. It will just check the value, and next will actually iterate the value. And now if I run this, you can see the output is still same, right? Now what next? So this is second way. Now let's implement the third way. Now to work with the third way, we can use enhanced for loop. So what is enhanced for loop here? You can simply use a for loop, And instead of defining the starting point and ending point, you can simply say I colon and you have to specify values. So this I will fetch data from values field or values list. Now how to print, will say S out and will print the value of I. And now if I run this, you can see the output is still same. Then question arises why we have this three different way. It's because this is the earlier way of doing it. So let's say if you want to print only from second value to sixth value, so you can use this for loop. Now iterators are used normally to print, to update, so you can do modification iterator also, or you can do modification iterator. But let's say if you want to print all the values, irrespective of the starting point and ending point, you can use enhance for loop. So if you want to print all the values, obviously the best option will be the enhance for loop. But if we talk about any of this loop, these loops are called as external iteration. They are external iterations. What if we can provide a feature called as internal iteration? So we have something called as internal iterations. So what's the difference between external iterations? In external iterations, some for loop outside of your object, it will try to fetch the data from the object. So same goes here. You can see all this loop, they do the same thing. They fetch value outside. What if in your collection, you'll be having a method using which you can increment? So that is called as internal iterations. And we can achieve internal iterations with the help of Stream API. Now how exactly we should be coding for Stream API, that we'll see in the next part of the tutorial. So in the last video, what we have done is we have created a collection object or a list object which is values. In this value, I had a value which is from 1 to 6. So I have used a arrays class here with a method called as list. So what we have done is we have used something called as external for loops or external loops to iterate from this collection. But instead of using external iterations, what if we can use internal iterations? So in order to achieve internal iteration, you can simply use something called a Stream API. Now what is Stream API? In Java 8, they have done lots of modification with your collection interface also, or collection API also. What I simply mean by that is you can just type values dot. So they have introduced a new method called as forEach. And if you go to the definition of forEach, you can see somewhere it will be written that it was introduced in Java 1.8. So you can using forEach method, so you can use a forEach method here. Now this forEach method needs an object of consumer interface. You can see there is something as consumer interface here. But since your consumer interface is a Lambda expression, or this is a functional interface, you can simply use a Lambda expression here. Now if you are not familiar with Lambda expression, you can go to my tutorials of inner classes. In that I have defined what is Lambda expression. But still, if you don't want to go there, I will be repeating the concepts with the same concept in the subsequent tutorial. Now, so let's see what is Lambda expression. Just define so let's go to this consumer interface. Okay, and it defines a method which is a method name here is it's not defined. Okay, the method name is accept, and this accept object which is one parameter. So what we'll do, we'll say I, a bracket, and we'll say S out. Again, for sure you will not understand this concept at start, but just be with me. You know, slow and steady will complete this concept of Stream API. So what we are doing here is instead of using external for loop, what if we can write this statement? And yes, if you write this statement, let me comment this for loop. And if I run, you can see the output is 1, 2, 3, 4, 5, 6. Then question arises how it works. See, forEach is a method which accepts an object of consumer interface. And what we are writing here, writing I arrow system.out.println, and in bracket we have I. Now what is happening here is, this is your functional interface. So if you are familiar with functional interface, it simply says for every value of I, it will print the value of I. So it will iterate from the first value of the values to the last values of the value. Okay, and so it will iterate from 1 to 6 and it will print all the values. So this concept is called as internal iterations. But the question arises, how exactly, what exactly this line is? Now to understand what exactly this line is, you can see my subsequent tutorials in which I will define what is consumer interface, how can you create a Lambda expression out of it, and what are the different features available with the Stream API. Now in this video, we'll see how this for each loop actually works. So to make it simple, let me remove all these extra comments which we were using earlier. And you can see now we have these two lines which says create a list with 6 values, and using this for each method we can print all the values, in which I have passed a variable which is I, and I'm printing the value of I. But let's say how exactly all this works. So let me remove this command again. Let me just remove this. We'll type it again. So we'll say values dot for each. Now this for each accepts a consumer interface object. So that means in order to work with this for each method, we need to create object of consumer interface. So we'll say consumer interface. So let's import this package, and you can see package name is java.util.function.consumer. So all these interfaces which were introduced in function package, they are Java 8 features. So if I go to this function package, you can see it was introduced in 1.8 version. Okay, so if you are trying all this code in Java 1.7, obviously it will not work. So in this for loop, what we have to specify is, we have to specify the object of consumer, and we'll say consumer takes all the integer value. So let me just go to the definition of consumer. If we go to consumer, it's a functional interface. A point to remember, it's a functional interface, and it says the version is 1.8, and this consumer accepts a type t, which is, if it is integer, so the type of this consumer will be integer. So for every consumer, so that your values, they will provide some data. So they are producer, and this consumer object here will be a consumer. Since it is a functional interface, you will be having only one method, which is accept. And this method accepts only one object, same as the type of your consumer. If your consumer is integer type, this will be integer type. So if you don't know what exactly this feature is, you can go to my video of generics, and you can learn what is generics here. So you can see we have a method which is accept, which accepts only one method or one parameter. So what we can do here is we can create the object of consumer, will say C equal to. Now in order to create the object of consumer, what we can do is we can create a new class here. So somewhere outside you can create a class, we'll say the class name is CC, and CC implements consumer. So you can do all those things, and then you can define a method which is accept. That's a feature of this interface. But what we can use here is we can use anonymous class. Notice anonymous class here. You can simply say new consumer. Again, if you don't know the anonymous class, you can go to my playlist of Java and search for anonymous class. So if you are familiar with anonymous class, please continue. So we have consumer integer C equal to new consumer, and we can specify the type again, which is integer here. We give a bracket. Now since consumer is not a class, it's an interface, we have to define the interface definition here, because every interface needs a definition. So either you can use a class to define the definition, or you can use anonymous class. So this thing here we are using an anonymous class. Now this consumer interface has only one method, which is public void accept. So we'll say accept, and it accepts only one parameter. So we'll say it is integer I. So that's your value I. And now let's print the value. So we'll say sout tab, and let's print the value of I. Okay, and then in this for each loop you can just pass, or for each method you can simply pass C. So what it will do, when you pass C, it will go to this object C. It will check, okay, we have accept method. So every time you call this for each method, it will fetch all the values, and one by one it will call this accept method and it will pass the values. So initially it will pass 1, output will be 1, then it will be 2, output will be 2. It will go till 6 now. So if I run this, the output is 1, 2, 3, 4, 5, 6. Clear? So that means this forEach method here, they accepts a consumer interface. Can we make this code more efficient now? Yes, we can. And how to make this code more efficient, that we'll see in the next part. Now let's make this code more efficient. Now how to make it more efficient is, now if you concentrate on this object here, so we are creating an object which is C. So in order to create the object of this C, we need to say new consumer, and then we have to pass this a method which is accept. Don't you think if you are using an interface which is consumer here, so obviously you have to write this line. If you are writing this line, obviously you have to define a method which is accept method. So why we are writing this? The only thing which is important here is this integer I, right? It's because every method will have multiple things, like it has a method name, it has method body, it has the return type, and it has the parameters. Now what is important here is, if you concentrate, this thing is constant, right? So every time you have to define this thing. This is also constant. So it doesn't matter, whenever you create the object of consumer, you have to define a method which is accept. So why to write accept here? The only thing which is important here is I. So what we can do is we can just change this code from here to here, and what we can simply do is, for every integer I value, this is my parameter. So your parameter value will be changed. For every value of I, what I need is, I want to print the value of I. So we'll say sys out. It's a system dot out dot print ln. So we'll say print ln, and this I will print the value of I. Simple, right? So we don't have to write everything like new consumer. We don't have to specify the return type, and we don't have to write the method which is accept, because that will be taken care by your Java. So all that code was, they were like a bottle, or what you can say, they are extra code which is not required. Okay. So what we have now is, we have specified the parameter name which is I, and using this Lambda expression, so this arrow is a Lambda expression here, we have specified the body which is system.out.println I. But if you know that your consumer type is integer, why we should specify an integer here? So we can remove that integer. And if you have only one parameter in your method, you can also remove this bracket there. So you can see we just have I, a Lambda expression, and system.out.println. And if I run this code now, you can see it still works. So it's from 1 to 6. But let's say, how many times I'm using this object? Only once, right? So what you can do, you can just copy this code from here. We'll say copy, and we can just paste this code on your forEach loop. So we don't require this thing. So this is what we have done in the first tutorial. So we have returned values.forEach I arrow system.out.println. So this is how we need to print all the values from your collection or from your list. So I hope you have got the idea of Lambda expression for forEach method. In the next tutorial, we'll talk about how to use different methods of Stream API. In the last video, we have seen how to use a method which is forEach to print all the values of list. So what we have done so far is, we have created a list of values in which I have assigned 6 values. So in order to assign values, we can use 2 ways. Either we can create an object of array list, and then we can add values. Otherwise, if you know the values at the start, you can use a class called as arrays.asList method to assign all the values. This method in turn gives you object of array list. So once you got the object with 6 elements, to print these values, we can use external iterations that we have done in the previous video. Like you can use a for loop, you can use enhanced for loop, or you can use something called as iterator. Otherwise, you can go with internal iterations using this forEach method. So forEach method here gives you internal iterations using which you can fetch one value and print that value. So we are taking the value and printing it. We are not doing any extra things here. Now, then you will say, okay, what is this arrow here? So as we have seen in the last video, this arrow means Lambda expression. So if you have an interface with only one method, so instead of creating the object, you can directly use a Lambda expression here. So when you talk about this forEach method needs an object of consumer that we have seen in the last video. So what we'll do is we'll see that method one more time. So we have returned forEach new. We can do in this way also. We can say consumer. We can create an anonymous class here. And this consumer we can create, we have to specify the type of element. So in this consumer we have to specify all these values are integers. And since consumer is an interface, you can go to this. Let me just first import the package. So if you go to this consumer interface now, it is written it's a functional interface. Now this functional interface, if you remember in 1.7 or 1.6, if you are using any version before 1.8, interface were of three types. First is normal interface with multiple methods. Then we used to have marker interface, which is an interface without any method. And then now we have this SAM interface. Now SAM stands for it is single abstract method interface, which simply means you have only one method in that interface. In this scenario, in 1.8, all your SAM interfaces, which is single abstract method interfaces, are called as functional interface. So what is functional interface? It's the interface with only one method declared. Clear? So you can also define functional interface with the help of this @functional interface annotations. Okay. So if we talk about this consumer interface, it has only one method. So we need to define that method here. So we'll say public void accept, and the value, the type of parameter it will take is integer I, and we can simply print the value of I. Right? So if you use this thing, it will do the same thing, or if you write this thing, it will do the same thing. If I comment this part and if I run this code now, it will still work. So if I run this, and you can see the output here, it will take some time. Come on, fast. Yeah. So you can see the output is 1, 2, 3, 4, 5, 6. It's because we have used a method here, which is a forEach method, which prints all the values. So if we talk about here forEach method, it's only take the object of consumer interface. Now if we talk about this consumer interface, it's a functional interface. So Java 1.8 says, if you have a functional interface with only one method, so this type of code here is called as boilerplate code, which simply means this forEach method only takes the object of consumer. So why we need to write this thing? So we can remove this part. Since we have removed that curly braces, we have to remove this one also. Now since that object there, which is consumer, has only one method, which is accept. So why to write this part? Right? So the only thing we have to specify here is only I, right? Which is the variable name. Why to specify this type when you know all the elements are integer? So we can remove this also. And then we can specify our arrow saying there's a method called as public void accept, which takes a parameter int integer I, and this is the code for that. So indirectly, this code represents public or new consumer public void accept integer I, and in bracket you have this. But since you have only one statement here, we don't have to specify a semicolon and a curly braces. So you can simply write this one. Now in turn, if you write this command, this is same like this one, right? So if you compare these two statements here, they are same. So what we can do, we can remove the comment and we can remove this part, and still the output is, if I run this, the output is same. You can see the output is same, right? Now that means, can I use a Lambda expression for all the interface? No, Lambda expression only works with functional interfaces. So if you have any interface which is not functional, Lambda expression will not work. Clear? So this is how we need to use Lambda expression. So in the next video, we'll talk more about other methods of Stream API. In this video, we'll see why we should not change the interface once it is published. Now what I mean by that is, let's say if I have an interface which is actor. Now this actor interface is in development state, it is not yet published. So what we can do is, in the development stage, we can add method declaration here. So to declare methods, what we can do is we can simply declare methods like, by default all the methods are public abstract, so we don't have to type that. What we can do is we can simply say it is void, and I need a method here. So this interface is actor, right? So what we'll do is we'll say this interface. So first the interface should say, let's say actor should act. So we have an interface which is act here. So we cannot define, so we can only declare it. So let's create we give a semicolon here. And let's say we have one more method here which says our actor should speak. Okay, because they want maybe a different way of speech. So every actor should speak. Yeah, that will go for these two methods. So in this actor interface, we have two methods. One is act and speak. Okay, so if you talk about any industry, maybe Hollywood or Bollywood, we need to have these two, which is act and speak. Now what we can do is, let's say I want to be a hero, or we need the object of hero. So obviously every hero need to implement an interface which is actor. So that a hero should know he need to do at least two things. First, he need to define these two methods. First method is public void act. We'll say s out, I can act. Okay, so first is he can act. Second method, he should be able to speak, because to speak or to make a dialogue, we need to speak, right? So I can speak. So now we have two methods, these two. But all these heroes, they have one more method, which is, let's say, comedy. So all these actors, they also do comedy now. Or all these heroes, they do comedy now. So we'll say s out, I can make people laugh. So we are writing these three methods. So what we have here is, we have this hero interface, a hero class, which implements our actor interface, in which two methods are compulsory, because every actor should act and every actor should know how to speak. But hero should be able to do comedy also. Now let's talk about, we have one more class which is villain. Now in this class, if I say implements, and let's say we are saying, okay, let's implement our actor, because all these villains are also actors, right? Now since it's a villain, we have to also say public void act. So in this we'll print I can act. We need one more method which is public void. Let's say this time it is one more method which is speak, because villain dialogues are more powerful than heroes dialogues. So we'll say I can speak. So now we have these two methods. But let's say villain has one more method which is let's say public void rudeness. So all the villains are rude. So we'll say I'm rude. So now we have these three methods. But let's say in future, hero says, no, I want every actor, or there's a system which says every actor should be able to dance. Now the problem is, after the definition of these three methods, what we have done is we have added actor, we have added hero, we have added a villain. So once they are published, in case in future, if you are making some modification, let's say if you are changing this actor interface, if you say public void and every actor should be able to dance now, Again, it doesn't matter is a hero or villain, he should be able to dance. And obviously, will not go for dance, we'll go for comedy. We'll say comedy. So every actor should know how to make people laugh. Now hero says, great, I don't have to modify anything is because I'm already implementing a method called as comedy. But what about villain? Now villain class will give you an error. Just imagine after publishing this interface, if you are modifying any interface, it's a crime. It's because all the classes which are implementing that interface will give you an error. And that's why you should never, never, never modify your interfaces. But hold on, you should never modify your interfaces in case of Java 1.7. What about Java 1.8? The problem is we are declaring this method and that's why villain says error, right? But what if you can define the method, right? If you can define the method here, this villain will not give you an error. But question arises, can we define a method interface? Yeah, that will answer in the next video. So, but till Java 1.7, we know that we should not modify your interfaces when they are published. Now, in the last video, what we have done is we tried to modify the interface once they are published. It's because once they are published, there will be lots of classes which are implemented that interface, which is actor. So what if in future I want to modify this interface? We cannot declare any extra methods, right? What about defining those methods? That means we are trying to define methods in interface. Is it possible? Java 7 says, or any version till Java 7 says, no, you cannot define methods in interface. But Java 8 says, hold on. What if a person needs to modify interface? We should allow him to add methods. But you cannot declare this because all the classes which are dependent upon that interface will give you error. That's why we should be able to define methods. And how to define is using a default keyword. So if you write a default keyword in front of your method, it will allow you to define. And once again, this thing will only work in Java 8. So if you are using Java 1.7 or that means 7, this code will not work. In this default method, we can simply say as out, it will print, I can make people laugh. Now you can see here, since I'm defining a default method, in this villain, you don't have any error. Even if I go to this hero and if I remove this method and there will not be any error is because we are defining that method there. So it's kind of inheritance or it's kind of overriding, right? It's because we are overriding a method which is a defined method. So yes, in Java 8, you can define methods in interface with the help of default keyword. Make sure you're mentioning this method as default. Once again, this method is public. Okay, so by default, all the methods in interface are public. So this is basically default public void comedy. Okay, so you can define a method. Now, what if I create a main function and if I create a main function or main method, and that if I create an object of hero and if I call obj.act, it will call this act, right? But if I call obj.comedy, obviously it will call this method default and it will execute. So it's the same like a method definition in a class, but this is an interface. That's why we have to define it as default. So a big mystery is solved. That is, we can define methods in interface. So in the last video, we have seen we can define methods in interface with the help of default methods. Okay, so we can define methods in interface using default methods, right? So let's say we are using this object values, and using values I'm calling a method which is forEach. But hold on, this interface, this list is an interface, right? So if I go to list, you can see this is an interface. Now that means this list belongs to a version which is 1.2. So it is there from 1.2 version. That means this method for each belongs to list, so it should be there from 1.2. But no, it is introduced in Java 1.8, right? So is it a declare method or define method? You cannot modify a interface, and that means you cannot add a declared method in interface once it is published. So that means this method for each should be a default method. So let's go to for each, and you can see this is a default method, which means you can directly use this method, which is for each. Instead of defining this method, you can directly use it. So this for each method is a default method. So all your latest interfaces which has latest methods, they all are default methods. Clear? Now let's see what are the extra methods it has, or what it says. So this for each method is not a part of list, it's a part of iterable. And list extends collection, and collection, if I click on collection, collection extends iterable. So this method for each comes from iterable to list. So they have not changed anything in list, they have changed things in this method interface called as iterable, and which is introduced in Java 1.8. So in future, if you are seeing any new method, any interface, so by default their methods are default. So in the last video, what we have done is we have created a list of values over 1 to 6, and then using this for each method, we have printed all the values using a Lambda expression. Now if you concentrate here, what we are doing, we are taking the value from the collection, which is from a list, which is 1 to 6, one by one. So first, initially this I will be 1, and then we are printing the value of 1, or I, which is 1. Then we are switching to 2, and then we are printing the value of I, which is 2. And then this is 3, and then this is 3, right? But what if, when we know that the only thing here will be one variable, and we are just printing it, then why even writing this 1? When this for each method knows that it need to take all the values from the list and it print it, or to do something, what we can simply say is, instead of taking a value, you take the value, you do anything. So for each will say, okay, I will take the value, tell me what to do. We are specifying here, for every value, print it. We will say now, for every value, you have to execute a method which is println. So what for each will say, okay, what I will do now is, if you say you are specifying a println here, what I understand is I have to write in this way. So for I will take a value which is I, and I will print the value of I. This is what you mean. I said yes. When I say println, this is what we need to do. It will say, okay, but hold on, I don't know what is println. So we need to say, okay, println is a method which belongs to object out. It will say, okay, whenever you say println, it's a method reference. So you are giving me a reference of a method, and whenever you want to work with method reference in Java 8, you have to specify a 2 colons here, which says you are working with the method reference here. And then you have to specify which object it belongs. And we say, okay, the object name is out. But hold on, what is out object? Out object is a static object of print string, which belongs to a class called a system. So you have to say it is system dot out. So this is the object you need, and in this object you will be getting a method which is println. So you can see we don't have to specify any variable I, and we are not using any Lambda expression explicitly here. We are using something called as method reference. So we are passing our method as a parameter. Now, is it possible? You might be knowing about call by. There's a method. There's something called as call by value. So you're passing a value. Call by reference. You're passing a reference of an object. Now we are looking at something called as call by method, and this is passing a method as a reference. Clear? So Java supports something called as method reference. So this concept here is called as method reference. So in the last video, we have created a method which is forEach, in which we are passing a method reference instead of using a Lambda expression. So if I run this code now, since we have not done in the last video, so we'll see the output is 1 to 6, right? So it's working. But hold on, is println is the only method you can use here? No, we can use any method. So let's switch back to Lambda expression here. So what we were doing is we are saying I colon, it is system, it is system dot out dot println, and you have to print the value of I. So this is what we were doing in the earlier tutorials. Now let's say I don't want to use here print this println. What I need is I want to print all the values into we'll multiply all the values by 2 and print it. So what we can simply do is we can create one more method, which is static method, public void public static void, let's say double the value. Also we'll say double it. So we have a method which is double it. It will take a parameter int I, and what it will return is, so we'll say return is int, it will return I into 2. Now, so we are using a method which is double it here. And I want to call a method which is double it. So what we can simply do is we can simply remove this thing, and we can call double it, and we can pass the value of I. And if I run this code now, yeah, so it is double it. Let's print it also. Let's print the value I into 2. So we forgot to print here, and we'll say it is void. So instead of going for int, let's go for void. And let's run this. You can see the output all is double. So from 1 to 2, 2 to 4, 3 to 6. So we're getting all the double values. Then you will say, is it the only way to print it? Can we use a method reference here? Yes, we can. So what we can simply do is, instead of fetching the value I and print it, we can simply say, I want to double it. Take all the values and call double it. But since this double it method belongs to a class Java 8 demo, we have to give a double colon so that we can say double it belongs to Java 8 demo class. And now if I run this, you can see the same output. So this is how we should be using method reference. So in the last video, we have seen how to use forEach method and how to use method reference. Now in this video, what we'll do is we'll remove this part, and let's go ahead with some new methods. And let me remove this part also. Okay, now still it. Now let's say I want to use the same list, and I want to print the values by doubling all the values. So what we can do is we can double all the values with the help of enhanced for loop. Now how to use enhanced for loop here is, we'll say first we'll define a method or a variable which is result, and by default the value of the result will be 0. And then what we can do is we can use enhanced for loop or a for loop or iterator to add all the values. We'll say int I colon, and these values will be coming from these values, and then we'll say result equal to result plus then it's I into 2. So what we are doing is we are doubling all the values and adding all the values which will be stored in this result. Or why to double? Let's first add all the values. So we'll go by step. So let's add all the values. Now once you got this, let's print the value of result here, and if I say run, you can see the output is 21, right? But hold on, what we are doing here, we are achieving something called as mutation here. It's because the value of result is continuously changed for 6 times. In fact, 7 times. First is here, and then it will be changed for 6 times. Just imagine how much mutation you are going for. So every time you mutate a value, it makes your system unstable. Maybe not unstable, but you cannot achieve concurrency here. So to make your system very fast, you need to achieve concurrency. To achieve concurrency, we have to reduce the mutation here. Okay, so even if I multiply by 2, we are achieving one more mutation, which is I into 2. So So if I run this, you can see the answer is 42, right? But then question arises, how to ignore this and how to ignore mutation. How can you write a code without achieving mutation? So what we can do is in Java 8 we got something called as Stream API. So Stream API says what you want to print. Values? Go ahead, print the values. Let me just comment this part also because we don't require a variable result now. Okay, what you want to print? Print the values? Go ahead, print the values. But no, you don't want to print the values. You want to print the stream of values. Now what is stream? Stream is a new method introduced in a collection interface or list interface. You can see if I go to this stream, it belongs to collection interface and it's a default method. Okay, so what this method will do is it will convert your collection into a stream. Now once you got the object of stream here, just have a look. This stream method returns you the object of stream interface. Now what is the stream interface here? This interface here, let me check, is it an interface here? If I go to stream, yeah, so it's an interface which has multiple methods. We'll not go into all these methods here. Okay, so it has multiple methods, and one of the method we have to use here is to double the values. We will use something called as map. So map needs an object of function, but instead of using function object here, we can use lambda expression. We can simply say for every value of I, for all the values of this values collection, take one value at a time, which is I, and apply the operation which is I into 2. So this map will give you a stream of values, and on that stream of values you need to find the addition of all the numbers. Now this reduce method will use object of binary operator. But instead of again creating object, we can simply use 0, 0, the initial value. So it will take two parameters. One is the initial value and then the binary operator. So we can use two values here. One will be C and E. C means carry, E means a value, and we can simply say C plus E. Okay, and I'm damn sure you will not understand anything from this. Don't worry, I'm not here to scare you. I'm just showing you the way a stream API can achieve the same operation without mutation and in less number of lines. Then you will say, what the use when we don't understand how to use it? Hold on. Once you're done with this video, in the next video I will explain what exactly this method interface or how this map method works. So if I run this now, you can see output is still 42. That means it's working. So this thing here is same like this thing. Then question arises how it's work, that we'll see in the next video. Now let's see how exactly this stream, map and reduce method works. So in the last video what we have done is we have created a list and that have 6 elements, and we are just multiplying each number by 2, and then we are adding all these numbers. Now to understand this topic, let me comment this part and let's do it again. So let me write this thing once again. So let me create some space here. I will say system.out.println, and in bracket I want to print values dot. So first we need to convert into stream. Now what this stream will do is it will convert all your values into stream. Now once you get stream, this stream object here, let me go step by step. What we need here is we need to create object of stream. We'll say stream s equal to values dot stream. Now this stream method will give you object of stream. Let me import the package. So you can see we have a package here, which is this. So stream belongs to stream package, and we can simply type here s. Okay. Now we don't want to create an object of stream. What we want is we want to multiply every number by 2. So what we can do is we can simply say s dot, there's a method called as map. So map will take a value and it will convert that value into the specified output you need. So what we can do is here we can say map, And this map object needs object of. So if you can search here, it needs an object of function. So before using map, we need to create object of function. So before the stream, somewhere here, let me create object of function. So how to get object of function? We'll say function for all the integer values. We'll say object name is f equal to new function here. And let me check the signature function first. Let me put the package. Okay, it's function.function. And if I go to this function interface, it takes two things. One, if you go to function, you can see it takes two generic values. One is the type of the value it will take, and second, the return type. So return type is R. So I hope you are familiar with generics topic. To understand this, you need to be very clear with generics. So it takes two parameters, integer and integer. So it takes an integer parameter and it returns an integer parameter. So here we have to specify both. So it's integer, and we can give a bracket and open and close, and we give a semicolon here. Since function is an interface, we have to define the methods. Now let's see which method this function have. And the method name is apply. And you can see this function is a functional interface. So function is an interface which is defined in version 1.8, and it's a functional interface, which means we can use Lambda expression, but that we'll use later. So in this function, it has only one method, which is public. It returns integer value, so we'll say it is integer, and the function name is accept. So we'll say accept, and it takes an integer I. It takes an integer I, and we can simply say for every value of I, return I into 2. Simple. Okay, we are getting an error here. Which object? Let me check. Okay, it's not accept, this is apply. So method name is apply here. Okay, so method is apply. We have to say it returns integer, it's accept integer. For every value of I, we can just return the value which is integer, which is I into 2. And somewhere here, we can just pass the object of f. So we can, if I give a semicolon here, you can see this map returns our object of stream. So now let me create one more stream here. We'll say stream s equal to, let's say this is s1. So this s1 has all the values which is multiplied by 2. If you want to verify, if I say stream dot, so stream also has a method which is forEach. Now you know how to use forEach. We'll use a forEach method here. And we can simply use a method reference with the system.out : let's print all the value. We'll say print ln. Okay, so we don't have to use s out here. Okay, so let me print the value of s. So if I say run, you can see stream has already. Okay, I made a mistake here. It's printing the values. Okay, let me print it later. So simply I will say s out, it will print s dot, it was values dot stream. Let's keep it there. Now if you come back here, what we have done is we have first take a stream which is all the values 1 to 6, and then we took all the values which are mapped. So it will multiply all the values by 2. Now this map returns a stream. So we got 2 stream now. Let me get one more stream which is s2. Now in this stream, I will say s1 dot reduce. Now what this reduce will do is, reduce will take the object. It will take 2 parameters. First is 0, the initial value, and then we have to specify the object of binary operator. So we need to pass the object of binary operator. Now how to pass the object of binary operator? That we'll see in the next part. Now let's see what this reduce method requires here. So this reduce method requires an object of binary operator. So let's create object of binary operator now. So somewhere here we'll say binary operator. So again, binary operator is an interface which is defined in which is in a package function. So it is introduced in Java 1.8, and we'll say the object name is B, and we'll say new binary operator. Now, if you see its definition, it only accepts one integer value. So it takes one integer value and it returns one integer value. Okay, so we'll say it accepts an integer and define a function here. Because it's an interface, we have to provide a definition. And let's see which method this binary operator has. Now, if you see binary operator function, this interface, it's a functional interface, okay, and it extends by function interface. And in this interface, you don't have any method which is declared. So you can see you don't have any method which is declared. All the methods are defined. What if I go to by function? And you can see in by function, we have a method which is apply, which comes to this binary operator. So the only method in this where we define is by function, this binary operator. Sorry, it is accept. Is it accept? Yeah, it's apply. So we'll say public, and the signature is it returns some value. We'll say value return is int, or it's integer, and the method name is apply. It accepts our integer value. We'll say it is I. And what we need to do here is we need to add this number. So let's say we'll say int total or int result, that what we have done in the last video is we said int is result will be 0. And every time you get a new value, we'll say result equal to result plus I. So this is what it does in the background, and we can simply say return result. Okay, and I guess there's a problem here. Okay, it takes two parameters. Yeah, it takes two parameters. Okay, it takes integer I and integer, let's say j. So we don't require this here. What we'll do is we'll say, what is the code? Yeah, we will simply return I plus j. The remaining thing will be handled by your JDK. We can simply say return I plus j. So every time it takes two values and it will add. So how it works here? Let's say if I pass the object of b here. So how it works? So initially, I'm still getting an error. Error is object cannot be converted into stream. Reduce what? Reduce returns. Reduce returns. It will not return a stream. It will return a int value. We'll say int. Let's say int result equal to. So this returns a integer value. It's an integer value. So we'll say integer, and we'll just cast it here. We'll say it is integer. Okay, so this reduce returns an object which you can convert into integer part. Now how it works? So this map will take all the values from 1 to 6 and it will map it to will multiply each number with 2. So this stream here will take all the values. This will take all the values and apply reduce. It will apply a reduce function. Now in this reduce, what we are getting is, so your values are, so after mapping, your value will be 2, 4, 8, 10, 12, and we'll have this 6 numbers here. I'm missing some number. I'm missing 6. Yeah. So you have this 6 number here. So initially it will take 2 and 0. So 2 plus 0 is 2. So this 0 and this 2 will go to this function as I and j. It will fetch the value. It will calculate it as 2. Then that 2 plus this 4, it is 6. Then 6 plus 6 is 12. 12 plus 8, which is 20. 20 plus 10, which is 30. 30 plus 12 is 42. Let's print the value of result here. So we'll simply say result. And if I run this, you can see the answer is 42. Now this is how your Stream API works. So what we have done is we have created multiple objects. We created an object function. We have created an object of function interface. We have created an object of binary interface. Now, how can you make this code more efficient? Now we'll make this code more efficient in the next part of the tutorial. Now let's make this code more efficient. So what we can do is, Since we are using this object f only once, so why we need to create the object? So we can simply copy this code, and instead of writing f, so we can just cut this code. We don't require this part now. So wherever you have f, we can simply paste the code. So this is what we have anonymous class, right? Now same goes for this b. So wherever you find b, we can just write this code. So I hope you are familiar with this inner classes concept. So if you know what is inner classes, you will understand what I'm doing here. So instead of writing b here, we can just, it's not working. Hold on, I've just not copied here. Okay, let me just cut this code. Let's say this is delete. And we'll go down, and instead of b, we'll paste that code. So now even if I run this code, the output will be same. So let's try to run this. If I say run as application, see the output is 42, right? So that means, let me close all these extra files here. Close, and close. Now you can see what we have done is we have created, we are not using anonymous object here, we are creating two streams. One S and second is S1. In S we are taking all the values, and in S1 we are fetching all the elements by multiplying by 2, and then we have found the result with the help of reduce function or reduce method of S1, which take two parameters, initial value and the object of binary operator. Now, as we have seen, this function here is a functional interface. Now, what function interface says is, in Java 8, if you have a function interface, what you can use is you can use a Lambda expression in which you can remove all the boilerplate code. So if you search from here to here, all this code is boilerplate code. The only thing is important here is this I. Okay, and we'll give I in a bracket. So this method, this means this is the parameter of your apply method, and this is the body. Okay, so you can reduce the number of lines using this. Now, since we are working with Lambda expression, you don't have to specify the return type also. You can simply say I into 2. Now, since I into 2 is only one statement, you have to remove the semicolon. And since you are removing semicolon, you can remove this curly braces. And you can say this is Lambda expression. Simple. Okay, now I have to specify the type of stream values here. So we have to say it is, the type of value should be integers. I forgot to mention this. Since you are following generics, you have to follow generics from start to end. And then we can simply say it is, we can write this thing in one line. So we can take out this I into 2. And then we can remove this, we can remove this bracket just because we have only one parameter. So if you are using only one parameter, you don't require those round brackets after with your variable. So you can write this in one line. So instead of defining an object, we can, instead of defining an anonymous class, we can directly use a Lambda expression. Can we use Lambda expression here? Yes, we can. So what we can simply do is, this binary operator takes two values, not one value. So instead of defining all this thing, let me write in this way. It takes two values. We can simply say I and j, and what it applies is, it will simply say I plus j. So it takes two values ij, it returns I plus j. So how it works, initially the value will be 0 and the first value, it will get added. That value will become I, and then it will be added with j. Now since we are using a concept of carry here, we can use something, or element name called as C and E, which is more logical. C is the carry and E is the value. Clear? So we can write this thing in one line. Now can we make this code more efficient? And the answer is yes, we can. What if, instead of writing S1 here and integer here, what if I simply write s.map function with I? I'm just defining the previous statement here. So instead of defining S1, we can simply write this thing, right? So I have removed that. Let me remove the comment also. So you can see what we have written is, we have simply written s.map.reduce and this function. If I run this, the output is same. Now if you say we can make this code more efficient, why to define s here when we can write instead of s, we can simply write values dot stream and bracket. So we don't require this thing also. Simple. And if I run this now, and the output is still same. Then question arises, why to write result when you can directly write this thing in println. So we can simply write it here. So we'll say it's paste. So we don't require this statement. And this is what we have done in the first tutorial of your map and these methods. Right? So it's that simple. Initially you will find it difficult, but trust me, it's not difficult, it's just unfamiliar for you. So once you start coding with Stream API, you will find it very easy to work with. In fact, when I started with Stream API for the first time, it was I guess in May 2014, I found it very difficult to adjust or very difficult to absorb. But after some time, I started working with all these different Lambda expression. Now, whenever I want to define an anonymous object, I prefer to go with Lambda expression if that interface is functional interface. It's that easy. So this is how we can use different methods, which is map, reduce in the Stream API. So let's run this code once again just to get the final output, which is 42. So in the last video, we have seen how to use this map method and reduce method. So map method takes a value and it maps it with any operation you want, and then this reduce, what it will do is it will try to aggregate or sum up, or it will try to find only one answer. So if you have a stream of values, and from that stream of values you can find one answer. Maybe an aggregation, maybe average, maybe addition, maybe some other operation, right? So this time what we have done is we have added 2 elements. But when you add 2 elements, instead of adding by yourself, you can use a sum method of interface class, this integer class. So integer is a class in Java, which is a wrapper class. It has a method called a sum. So we can simply say it is integer, or we can say it is take 2 values, c, comma, e, and for every value, apply a function which is integer dot sum, and we can pass c comma e. So it will take these 2 values, it will send it to sum, and that this sum will return your value. So if I run this code now, you can see output is still 42. So either writing c plus e, you can simply write integer dot sum c comma e. So sum is the inbuilt method of integer class. So if I go to sum, you can see it's a static method which returns an integer value. But hold on, which is better, writing c plus e or this? Of course, c plus e, right? It looks good. But what if I say, whenever you work with a method of a class, you can also use something called as method reference. So here we can simply define integer colon sum. So we can skip that 2 variables. So it will automatically fetch 2 values and it will apply a sum operation. Right? So we can say run. You can say it is 42. Simple. So this is how we have to use pre-built methods with the help of reduce method in Stream API. So in the last video, we have seen how to use these methods which are map and reduce. Now in this video, we'll do some modification, and let's go for a new logic here. Okay, so what we'll do now, instead of having these values, let me change the value. We'll say the value is 12, 20, 35, 46, 55, and 68. So I'm going for this random values, and let me go for one more value, which is 75. So these are my values, which is 12, 20, 35, 46, 55, 68, and 75. Now what I want to do here is, I want to add all the elements, which are divisible by 5. Now that means I want to add this 35, 55, and 75, or even 20. So all these numbers are divisible by 5, and that's why I want to add these numbers. Now in order to do this with the help of collection, for the logic of collection, what we can do is we can use a for loop. In fact, we need one more variable here. We'll say int result. initial value of result will be 0. And in this, what we can do is, we can apply a for loop. We'll say int I in all the elements of values, or all the values, which is a list here, and fetch one value, check that value. If that value is divisible by 5, how to check? We'll say I mod 5 is equal to 0. So by this, you will get all, you can check the number is divisible by 5 or not. Once it says true, it's divisible by 5, what you can simply do is you can say result. We can use a shorthand here. We'll say result, or we can say result equal to result plus I. Now since we can also use a shorthand here. Instead of writing result equal to result plus 1, what we can simply do is we can just remove this part and we'll say a plus on this side. This is a shorthand for result equal to result plus 1, result plus I. Okay, and then that's it. By doing this, what we get is a result which is S out. If I put in the value of result here, so it should give me 20 plus 35, which is 55, 55 plus 55, which is 110, 110 plus 75, it is 185. So the output I'm expecting here is 185. Okay, so let's run this code to check if we are getting the right output. And okay, yeah, and the answer is 185, right? So we can use this logic, or since again, if you're doing in this way, this is external iteration, and we have to apply all the logic. Now the problem is this type of codes are called as imperative coding, which means you have to focus on both the things. Is it what to do and how to do? Now if you do the same thing using Stream API, Stream says you only focus on what to do. I will take care of how to do it. So what we can do is we can just simply say S out, and instead of using external for loop, we can use an internal for loop. We'll use a for values dot. There's a method called a stream. It will convert your list into a stream. Then from the stream, now I want to remove all the values which are not divisible by 5. I want to remove this 12. I want to remove this 46 and to remove this 68. Now how to remove? So there's something called as filter. Now filter is again a method of stream which takes a true or false value. Now how to represent a true or false value here? I can simply say for every element of I, the body will be I mod 2 is equal to 0. It's not 2, it's 5. So I mod 5 is equal to 0. If this will remove all the elements which are not divisible by 5. So it will only forward those values which are divisible by 5. Now once you got the filter, now we need to add. How to add? We have already seen that using reduce operator or reduce method. We need to pass two values. One is C comma E, carry and the element, and we'll apply C plus E there. Either you can use integer colon sum, which we have done in the last video, or we can directly use this thing. And if I run this, I should be getting 125 two times, 185 two times. Yeah. So this one answer with this logic and second answer with this logic, much simpler, right? And the advantage is this is internal iteration. Clear? Now, how this filter works, that we'll see in the. So now see, we know how reduce works, right? We have seen in the last video. It takes an object or binary operator. What about this filter? Now, to understand filter, we'll see the next video. So in the last video, we have seen how to use this filter method. So in this filter method, you can filter out all the elements which you are not required. Example, with this logic, it says use only those values which are divisible by 5. So what this filter will do is it will give only those values to reduce which are divisible by 5. In fact, whenever you work with this stream methods, or this is also called as functional programming, because you don't have to focus on objects. We are focusing more on functions. You can say this is a function here, again a function, and a function. So no need to create the object, which we have a habit of doing in Java. So stream says If you want to make this code look more beautiful, what you can do is after every function, give a enter and line it up so that we can see it in a better way. It looks much better if you write one after the other. So this stream will convert all the values. Then all the values will go to filter, and only those values will come out which satisfy this condition, and those values will go to reduce. Simple. But let's say how exactly this filter works. Now if I remove this code, or let me just comment this part so that you can understand what I'm doing here. Okay, and let me comment all this thing also. I guess you have you know how it works, so let me remove this thing so that our code will be more it will look more simpler. Now let me write the thing once again. So I will say sout values dot, it will convert into stream. Now this stream will accept we'll say a dot. We'll say a dot, and we'll say a method which is filter. Now if you check this filter says I want an object of predicate. Now you can see there's something as predicate here. Now what is predicate? Now predicate is a functional interface in Java which was introduced in Java 1.8. So filter needs an object of predicate. Let's the object of predicate will be P. So that means I need to create object of predicate. So let's create. So we'll say predicate. If I see the signature of predicate, it accepts only one value. So the type is only one. So you can see predicate is a functional interface which takes only one argument, and it returns a Boolean value. So what we'll do is we'll say the type of all the elements are integer. We'll name this object as P. Since it's an interface, we cannot directly create object using new keyword. We need to define it. We'll say we'll define it here, and we'll give a semicolon. And we have to also specify the type, which is integer. Now we need to import the package. So we'll say Control-Shift-I, which will import the package. And you can say predicate belongs to a package which is java.util.function. Okay, and we'll say OK. Now once you have done with the import, we need to say whenever you provide a definition of interface, you have to define all the methods. Now let's go to this predicate interface, and we'll see which method we need to define. So predicate is a functional interface. That means this interface will support Lambda expression. Next, the only method it has is the method name is test, which takes a parameter and returns a Boolean value because it checks for the condition. Now we'll define that method here. We'll say public. It returns a Boolean value, and the method name is test. It accepts a value. So we'll say it is integer I. Now, it only returns a Boolean value, and when I say I mod 5 is equal to 0, obviously it will return a Boolean value. So if your number is 12, 12 mod 5 which is not 0, it will return false. Now what this filter will do is, if it returns a false, it will remove that element from the stream. Simple. So this is how it works. This is your predicate here. Now we can simply say, since we are done with the filter, we'll apply a reduce function. We'll say reduce with the same logic what we have done earlier. We'll say 0 comma in bracket C comma E, which takes up value, and we'll use a Lambda expression here, and we'll simply say C plus E. Again, we know how to use it. We have seen in the last video. Now, so I have created a predicate here, and I have passed that object P here in this filter. So once again, what is predicate? Predicate is an interface which was introduced in Java 1.8. It's a functional interface which has only one method called as test. So in order to create the object of predicate, what you have to do is we have to say predicate P new predicate, where we define the class, and we have to define the method which is test. And if I run this code now, you can see the answer is 185. Simple. Can you make this code more efficient? And yes, we can make this code more efficient. Then question is how? That we'll see in the next video. Now in this video, we'll make this code more efficient. So what we have done in the last video is we have used this method which is filter, in which I'm passing the object of predicate. Now this predicate is an interface, a functional interface which has only one method which is test, which takes only one parameter and returns a Boolean value. So in this function, you can define any logic you want. Like you can filter the elements depending upon prime number. You can also, let's say you have a collection of students, or a collection of students in which you want to filter out all those students who got maybe about 60%. So you can do that also. So we can achieve lots of things using predicate. Now, if you focus on this P, don't you think we are using this P only once? So what we can do is we can cut this part here, and we can write the same logic in this filter method, and we don't need to use this filter predicate P now. Now, if you focus on this code here, from this point to this point. Now this predicate is it's a functional interface, and if we are creating the anonymous inner class, you can see NetBeans itself gives you a suggestion. It says this anonymous inner class creation can be turned into a Lambda expression. Mind you, this suggestion will be only available in NetBeans 8. If you are using any version which is before NetBeans 8, it will not give you that suggestion. In fact, it will not support all these different APIs. So we can convert this code into a Lambda expression. So you can see from here to here we have a boilerplate code. So what we can do is we can rewrite the code. So let me just cut this part. We can rewrite the code in this way. So this takes an integer value, and what we are doing is we are checking that value is more equal to 0, right? That's it. We can see the same code here and here. And if I run this code, it's working. The answer is 185. Clear? So this is how we should be using streams, we should be using filter, we should be using reduce. Let's say before adding, I want to multiply each number by 2. Again, you can use something as map. This map will take a value and will convert that value into a double of it. So we'll say into 2. Simple. The answer will be after doubling each value, the answer should be 370. Yeah, answer is 370, right? So this is how we can use a filter method with the help of predicate interface. Now, if you focus on these two methods, don't you think this sounds like map reduce of Google? Yeah, so this is how Google works, right? They first map all the elements, and then they try to reduce the elements so that the searching will be easy. Okay, so this is how we should be using a predicate interface. Then you will say, okay, I don't want to reduce. I want to find the first element. Okay, so the first element which is divisible by 5, which is 20, right? I want to print the double value, or the value of that 20 into 2. So what we can do is we can just multiply it by 2, and we don't need to reduce here. What we want to find is we want to find first. So there is an inbuilt method which is called as find first here. So if I run this code now, you can see the output is optional 40. But hold on, what is optional here? Now Java is very efficient. It says there is a possibility that in your list you will not find any value which is divisible by 5. There is a chance, right? In that scenario, I don't want to give you 0. I don't want to give you any error. And that's why I'm giving you the output as optional. Let me show you. Let me say the values are 6, 88, and 99. Now these values are not divisible by 5, right? So if I run this, you can see the answer is optional empty, which simply means you don't have any element which is divisible by 5. So it will reduce the bugs in your code. Okay, that's why I just love this Java new API, which is Stream API, which provides you many features, and it will help you to reduce the number of bugs you have. So this find first function will give you the first value with the help of optional. But let's say I don't want to print optional, or I don't want to print optional empty if you don't have any element. I want to print a value 0 in case if you don't have a value. So in that case, we'll simply say or else. We'll use or else. It should print 0. So this will find first. If you don't find any value, it will print or else. So if I run this code now, you can see the answer is 40. And if I don't have any element which is divisible by 5, which I say, again, they will go for the same value, 6, 88, and 99. If I run this code now, you can see the answer is 0. So this is how we need to use a find first function and or else function, which if your find first failed to pick up any value, it will print the value which is 0. In fact, you can write any integer value here. Simple. So let me just change the value. Let me go back to the previous values. Okay, let me run this again for the surety, and you can see the answer is 40. Then question arises, is it code more efficient? Yeah, we'll talk about that in the next tutorial. So what we have done so far is we have all these values, which are seven values in the list, and we tried to print on the first divisible number by 5, so which is 20 here. So what we have done applied a filter which filtered out all the elements which are not divisible by 5, and then the remaining elements which are divisible by 5 will be mapped to multiply by 2, and it will find the first value. Now if I do the same code with the help of a normal for loop, let's try to do it with a normal for loop. We'll say int I colon values, and in this, first we need to check if my value, which is if I mod 5 is equal to 0. So if it is over 5, then I have to multiply that number by 2. We'll say it is I equal to I into 2, and then break. Okay, because we want to stop it, and then we can just print the value of. I want to print the value. I cannot say value here. I will say int result equal to 0. I cannot say I into 2. I can simply say it is result into 2. Now if I run this code and if I print here result, let me print result here, and if I print it now, both the code should give the same answer, which is 40, right? So both are taking the same value. Now if I check the number of iterations this loop is taking and the number of iterations this thing is taking. So let's start with this. So the first value of I is, let's say the I is 12. Let me remove this code since we have done with this. Okay, so the first value of I is 12. Is 12 divisible by 5? No. Second value is 20. Is it divisible by 5? Yes, and you will get the break. So only 2 times this for loop is incrementing. What about this stream? This stream is working with all the values. Then we have removing this, we are taking only 4 values, 20, 35, 55 and 75. And then 4 values, we are applying a map, and then we are finding the first. If you know 20 is the only element you want, then why we are applying all the operations with on this 35, 55, 75. So this stream here is wasting our time by filtering all the elements, by mapping all the elements, and then finding first. So if we talk about the efficiency, this code looks more efficient, right? But is it? Stream is a new API which was introduced in Java 1.8. So is it less efficient than for loop? Of course not. It's a new API, new features, and it should be more efficient than the for loop. Then question arises, how it actually works. Now if we talk about this method like filter and map, these are called as lazy methods or lazy functions. They go for lazy evaluation. Now what is lazy evaluation is, when you say values.stream, this stream will say, okay, I have done my work, which I have converted all the values into stream. Then you say filter, now it's your work, filter all the elements. Filter will say, okay, done. Then you will ask map filter, map all the elements. Map will say, okay, done. Once you say find first, now this find first here is not a lazy method. It's a eager method, or you can say it's a terminal method. It will terminate. If you go to the find first, you can see it's written here. Okay, let me click on more. So this is a terminal operation, which means when you say filter all the elements, he will say done. Map will say done. Find first will say, okay, if you are done with your work, give me the first value. Map will say, okay, I have not completed my work yet. First, let me map it, and then I will give you. Map will ask the value to filter. Filter will say, okay, let me do my work and I will give you. That means once when I say filter, it will not filter. It will just say I've done. When I say map, it will not do its task. It will simply say done. It's like lazy people. When you ask to do something, they will say okay done, but they have not done it. When you ask for a result, then at that time they will do. It's something like your assignments. If I give you assignment for 1 week, and at the end, in between, if I call you and ask, have you done with the assignment? And the answer you will give is, of course, yes, right? I have done with the assignment. But if I ask you to send me a pic of that assignment, it will take you 5 hours or 10 hours to send me the pic. It's not because you are taking the pic for 10 hours, you're writing the assignment at that time. So map is like a lazy you. Okay. But find first is me, I'm asking you the result. So find first is a terminal method. So these two here, they are lazy. Then question is how it exactly works is, find first will ask a map that I just want only first value. Then map will say, okay, why I will map all the elements. I will map only the first element. Then we'll ask a filter. Filter will say, okay, map will say, see, I want to give only one element to find first. Don't filter all the elements. Find the first element which is divisible by 5. It means this filter will take only one value and map will take only one value. So let me run this. The answer is same. Then how to prove my point? Now to prove my point, I will define some methods here, but how exactly I will write those methods, that we'll see in the next part. Now, so let me prove my point here. For that, what I will do is, first I will remove this extra part. Okay. So in this, what I will do is, I will define one more method after this method, which is public static. It returns an int value, and we will say that the value is, the method name is divisible. We'll say is divisible. Okay, so we'll define this method which takes only one parameter I, and what will return is, okay, it's not int here, we'll say it's a boolean because we want to check. We'll say return I mod 2 or 5 equal to 0. And here, what I will do is, before checking, it's directly we'll do return here. And we'll define one more method which is public static int. We'll say map it or map double. We'll say the method name is map double, and it will take one value int I, or what it will return is the double of that value, which is 2, I into 2. So instead of applying a Lambda expression here, we can use a method reference now. So we can simply say my class name, which is Java 8 demo, colon is divisible. And here, instead of using again a Lambda expression, we can use Java 8 demo, colon, it is map double. Okay, and if I run this code, you can see the same output, which is 40. But what if, before returning the value, let me print this. Let me print something here. We'll say sout is, we'll say n is divisible. I will use short form here. N indivisible, and for the value which is I, and in this also let me say sout. Again, we'll print in map double plus for the value of I. So if you are filtering all the elements, it should print all the elements. If you are mapping only divisible 5, it should print all the values divisible 5, right? But since it is lazy evaluation, you can see it is only executing for the 12 and 20. So filter is applied only to 2 values and map is only applied to 1 value. So this is more efficient than the for loop. It's because this filter here is, this filter and map, they are lazy methods, and find first is the terminal function here. So I hope I have proved the point here, which is lazy evaluation. Simple. So this is how we should be using a filter method. We should be using to call it more properly, we say it's a filter function. a map function, and find first or else function.